The next thing I need to tell you is something called the identity matrix. Well, the identity matrix is the matrix that does nothing. Okay, so what does it mean to do nothing? I don't mean the matrix 0. The matrix 0 would take X and would always give you back 0. That's not a very interesting transformation. What I mean is the guy that takes X and gives you X again. So it satisfies property I, so it's called I, and it has the property that Ix equals X for all X. So it's the transformation from something to itself. It's the obvious transformation called the identity transformation. So how do we write that as a matrix? Well, so actually there's an identity for each size, because of course, depending on whether X has 2 entries or 10 entries, the matrix I needs to have a different size. So, for example, the identity matrix of size 3 by 3 has entries 1, 1, 1 on the diagonal and zeros everywhere else. Okay, let's check. If we multiply this with a vector, well, okay, maybe I should do that on a separate board. But so start thinking about it. What happens when I multiply this with a vector X? Okay, so let's say I multiply the matrix I with a vector x1, x2, x3. Well, what will be the first entry? It will be the dot product between 1, 0, 0 and x1, x2, x3. If you want, this vector is I hat. Okay, so if you do the dot product with I hat, you will get the x component. You will get the first component that will be x1. 1 times x1 plus 0, 0. Similarly here, if I do the dot product, I get 0 plus x2 plus 0. I get x2, and here I get x3. Okay, it works. Same thing if I put here a matrix, I will get back the same matrix. Now, of course, okay, so in general, the identity matrix in size n by n, so it's an n by n thing with 1s on the diagonal and 0s everywhere else. Okay, you just put 1 at every diagonal position and 0 elsewhere. And then you can see if you multiply that by a vector, you will get the same vector back. Okay.